Hi, I'm Peter, and this is my friend Jonah.
Hi!
We're here to tell you about Newton's laws of motion and how they relate to sports. Hello, Mr. Driscoll. Can we have a paper on Newton's laws, please? We need to study them today.
Sure, guys. Here you go.
Thank you.
The first law of motion is called the law of inertia. It says that something in motion will keep moving unless something interferes with the object to make it rest. If an object is stationary and is interfered with by an outside force, it will go into motion. The second law says that when an object is at rest, it has inertia, the tendency to be stationary. Only an unbalanced force will cause the object to come out of inertia, but an object with more mass with the same force will have less acceleration, and a larger mass allows for more force. The second law states that an object will only accelerate when an unbalanced force acts upon it. An object with more mass with the same force acted upon an object will have less acceleration. The ability to generate a bigger force will cause more acceleration. Remember, force equals mass times acceleration.
The third law states for every action there is a reaction of the same or opposite level of force.
Okay, guys. Time for gym.
I can't believe Isaac Newton came up with the concept of gravity when an apple fell out of a tree and hit him in the head.
I know, that's so weird.
Where's our gym teacher?
Hello, I'm Dr. Cool, and I'm your gym teacher today.
Hey, Dr. Cool, do you remember us 2 years ago when our friend had a stroke? Wait a minute. That was at 11 years old.
Yes, I remember him, and you're Peter and Joe... No.
It's Jonah.
Yes, Jonah. Okay, let's play golf. Well, here you go, kid. You try. Okay, class, what just happened to the ball?
You failed horribly.
Shut up. Anyway, the ball had inertia, the tendency to stay still, and when I hit the ball, I was the unbalanced force causing it to go in the hole, aka in motion.
Wait, I hit the ball.
Sure, Jonah. Anyway, now, time for soccer. I love soccer, yeah! Okay, class, what happened to the ball?
You kicked the ball, causing it to accelerate.
My turn to talk. Anyway, I kicked the ball, causing it to accelerate, because I have more mass than it accelerated. If my mass was equal to the ball, it would not accelerate. But if Peter kicked it and I kicked it, I would kick it further because I have more mass and I can generate more force. But if somehow Peter can generate more force, then he will kick it further than me. Just remember, force equals mass times acceleration.
Wow, I didn't realize Jim uses science, but cut the monologue and let us play the game.
But why? When can we can play football? Okay, so I'm going to run through that guy over there. I'll get the helmet. Here's a helmet like today's football players wear.
But wait, your head still isn't safe as it could be. I'm learning about this in science. Anyway, you're still at risk of many head injuries.
Yeah, this diagram shows you a lot about the helmets. You can see that these helmets are designed with the little spokes inside the helmet that are absorbing all of the impact. But the issue is the spokes aren't even absorbing much of the impact, and your head is still taking a lot of the hit.
Yeah, but the only way to stop the head from taking too much impact is to increase the amount of time of impact. It'd be like smashing your head into a wall, then doing it again in slow motion. By doing it in slow motion, you're increasing the amount of time that your head is against the wall. This is what needs to happen inside the helmet when there's impact in football, and there's impact with another player.
So what are you suggesting?
Right now, scientists believe that if they can find a more absorbent material, that they can increase the time of impact and get less head injuries.
Yeah, we think that using memory foam and sheet metal could possibly solve the issue. The reason for these is that they are absorbent and can increase the time of impact to help with less effects to the head.
See, right here, we suggest putting sheet metal, and right here. And instead of these spokes, put in memory foam, and put memory foam on the inside of the helmet where the players' heads are.
Oh, I see. This supports Newton's laws of motion. Also, the third law says that for every action there's an equal opposite reaction with the same or opposite amount of force. When a player collides with another player, the helmet is acted upon, And the opposite reaction of the helmet is when it pushes against the player's head in the opposite direction. But because the player has inertia, they want to continue forward, and the helmet pushing back against it still means a lot of collision is happening. But with absorbent materials, they are absorbing the equal opposite reaction and sending that reaction the way it came, back outwards. This will cause for much less collision inside the helmet.
Exactly.
On the bright side, I don't have a concussion. Now time for some real-life examples.
Newton's first law states something in motion will keep moving unless something interferes with the object to make it rest. In this case, the soccer ball is moving, and then the fence makes it stop. The first law also states if an object is stationary and is interfered with by an outside force, it will go into motion. My foot is the outside force that is interfering with the ball, which is stationary, causing it to go into motion. Here you can see the soccer ball hitting the basketball. Both are accelerated at each other with the close to the same amount of force. But because the basketball has more mass, there is less acceleration in the equal opposite direction, like stated in the third law. Newton's third law states for every action there is a reaction of the same or opposite level of force. The action here is the soccer ball being kicked at the second soccer ball, and the reaction of the force from the first soccer ball is the same amount of force being transferred into the second soccer ball, making that one move.
For our experiment, we kicked 2 soccer balls with the same mass at each other with the same force. Knowing Newton's third law of motion, we know that once they hit each other, they will bounce back with the equal or opposite amount of force. They both bounce away the same amount, which proves the third law. Once we kick the basketball and the soccer ball together with the same force, the basketball has more mass, so it will have less acceleration than the soccer ball. This supports Newton's second law, because it says that acceleration will equal force divided by mass. So the basketball with more mass will have less acceleration. This would apply with the equal opposite reaction as well. And that is what you see here.
Now you know a lot of things use Newton's laws of motion, including gym class. The first law states that an object will stay moving or stay at rest until acted upon by outside force. The second law states that the more force able to be generated will cause more acceleration. The third law says that with every action there is an equal and opposite reaction. All the laws work together and make sense of how any object moves or stays stationary.
11 years old.
Yes, I remember, Will. Troubled boy. I freaking cracked my knuckles!
Well, here you go, Trid. Trid? What's a trid?
Or we're using that clip. We're using that clip. Hey, finally, took you long enough.